In this part, I want to talk about the systems of linear inequalities in two variables. Okay, so here is the example. We use the example to illustrate this topic. So this is the example. This is a system of linear inequalities. 3x plus y less than 9 and x minus y greater than 7. Okay, and in the last section we know that a linear inequality, the solution for the linear inequality represents a region, right, half plane in the plane. And so this is a system of linear inequality. So that means we need to find, so each one represents a region, half plane in the plane, and this one represents another half plane. So if we need to find x, y, satisfy these two inequalities at the same time, so we need to find which is called the overlap, the common region, right? So we need to find the common region, but the strategy is still same. We can draw the graph for the first linear inequality, right, to find the half plane for this solution for this linear inequality. Then we draw the linear inequality, the solution region for this linear inequality. Then we can see where is the common part. The common part would be your solution for this system. Okay, so now let's look at each one. So first, let's look at the first one, 3x plus y less than 9. So for the linear inequality, we know we need to look at the line, the boundary. The boundary is given by this one, right? 3x plus y equals 9. So we need to find 2 points, right, to draw sketch the graph. So for example, if we set y to be 0, so x would be 3, right? So this is 1 point. The other point, if x equals 2, so y equals 3. Okay, so we can use these 2 points to locate the graph. So this is the 1, 2, 3, 4, 5. Okay, and here is 1, 2, 3, 4, 5. Here's 1, 2, 3, 4, 5. Okay, when x equals 3, y equals 0. So this is the 1 point. This is 3, right? When x equals 2, y equals 3. 1, 2, 3 is here. Then we connect these 2 points because this inequality is less than, so this line should be a dashed line. That means for this inequality, this boundary is not included, right? So let's use the dashed line. Okay, so this is the boundary of this inequality. Okay, then which part, right? It divides into 2 parts, right? Which part is the solution region for this inequality? Let's just pick an arbitrary point, right? If the point in this way, we pick an arbitrary point here. If the point satisfies this inequality, then this region containing this point would be the solution set, right? If the point here, if we pick up this point, if the point in this region satisfies this inequality, then this region would be the solution region. If the point here, it does not satisfy this inequality, then the other part would be the solution, right? We just pick up arbitrary point. Okay, let's pick up this point, 0, 0 point. Right, this is very easy to calculate. So it's 3 times 0 plus 0 would be equal to 0. 0 is less than 9. Yes, this is correct. So this region, we use another color. Okay, we just use black color. This region would be your solution. Right? This region would be your solution. So now let's look at the other part. The other part is x minus y equals greater than 7. So x minus y greater than 7. So we still pick up arbitrary 2 point. Let's pick up the x equals 2, then y equals. So again, we need to look at the boundary. That the boundary is given by y, x minus y equals 7, right? So we can have x equals, we pick a point 2 and negative 5, right? This is the 1 point. The other one, x equals 3, then y equals negative 4. So let's locate these 2 points. Okay, we use other color and the red color. So 2, negative 5, 2x equals 2 is here. 1, 2, 3, 4, 5 is here. Okay. The other point, this is the 2 and the negative 5. 2, negative 5 is 2, negative 5 here is 3, negative 4, 3. Okay, and negative 4. Negative 4 is here. So because here is greater than, not equal to, right? Not greater than, equal to. So just greater than, so this line should be a dashed line. So this point would be the dashed line. Okay. So which part, right? This red line divide our plane into 2 parts, the upper part or the lower part, right? So which part is the 1? So we just pick arbitrary 0. Let's pick 0, 0. This is for our convenience. We can pick arbitrary number, right? If we pick a number here, point on the in the lower plane, it's hard to locate, right? And the number is great, so it's large, so it's not easy, right? So we just pick not convenient, so we pick the origin. So it's 0 minus 0 equals 0. 0 greater than 7? No, it's wrong. It's wrong. So it's not greater than 7. So this point should not be the solution part. So in other words, the upper half plane would not be the solution region. So the lower, so it would only be the lower half plane. Right? So can you see the common region? This would be the common. I use another color to help you to locate. So this would be the common region, right? So this is the boundary. This would be the common region, right? Both have the black lines and red line. So this is your solution set. Okay, so this is your solution set. So you see, the system of linear inequality is nothing. You just draw the graph or separately for each inequality, then find the common parts, right? So since you see this is the boundary, but you see the region, you can extend the region below forever, right? So on this side, there is no boundary. So this is called unbounded. Okay, this is called unbounded region. So now let's look at another one. Okay, oh, I forgot here is a point which is the intersection point. What is this point from? We will learn this point later in the next section. This point is from this to the intersection of 2 lines. So it's the 3x plus y equals 9 and the x minus y equals 7. So if you solve this linear system, right? We have learned in the section for the linear system, and it would be x equals 4, y equals negative 3, which is this point. This point is 4, negative 3. We give a name which is called a corner point. corner point. In the next section, you will see the corner point play a very important role. Okay, so this is some concept for the corner point. So now let's look at the next example. The next one is 2x minus y less than equal to 8, x minus y greater than equal to 6. Okay. So again, so we need to find 2x. The first one is 2x minus y equals 8. Okay, so we draw this graph. So we can see if y equals 0, x equals 4, right? This is one choice. If x equals 3, then y equals what? Negative 2, right? This is another choice. So let's locate the graph. And since this is equal, so the boundary should be a solid line. So that means the boundary is included, right? Here is less than equal to, not just less than. So less than equal to. So that means the boundary is included. So this is 1, 2, 3, 4, 0, right? 1, 2, 3, 4. So 3 when x equals 3, which is equal to 2. So which is this point, negative 2. Right, so then we connect these 2 points. So this would be the line. So, but which region, right? Which region? Okay, so this is we just pick an arbitrary point, 0, 0 point. Let's this time we don't pick 0, 0. Let's pick this point, 1, 0 point. Okay, let's pick 1, 0 point. To see if this one is in the region. Okay, so 1, 0 point is 2 times 1 minus 0 equals 2. 2 is less than equal to 8. Yes, this is correct. So that means this region, the up half plane, would be the solution set for this inequality. So now let's look at x minus y greater than equal to 6. X minus y greater than equal to 6. So this, we still look at x minus y equal to 6, right? So we can pick a point that x equals 2, y equals negative 4. This is the one point, right? X equals, you just pick arbitrary point for your convenience. 3, and then y equals negative 3. Okay, so we just pick up these 2 points. 2, we use another color. 2, negative 4. 2 is here, negative 4 is here. So 2, negative 4 is here. Yeah, if you draw the character, it should be on the graph. Okay, 2, negative 4. If you plug in this point 2, negative 4 into the first 2x equals 2, so it's 4 minus negative 4 is 8. So this point should be on the graph, right? If you draw the graph precisely. And this is the one point on the line. So the other point, 3, negative 3. 3, negative 3. Okay. 3, negative 3. So then we connect these 2 points. So this one is an equal sign, okay? Greater than equal to. So this boundary is included. So we just connect it. Okay, so you see, but which plane? Okay, so we still pick this point, the 1, 0 point. We still pick 1, 0 point to test the region. Test the solution region. So we plug in 1 minus 0 equals 1. 1 is greater than or equal to 6? No, this is wrong. So this point should not be in the region. So the region should be below this red line. Okay, this red line divides our region into the upper half plane and the lower half plane. But this point is not in the solution region, so the solution region should be the lower half plane, right? So, but what is the common part, right, from this graph? I use the purple color. So the common part would be here, right? This line and this line. This would be the common part, right? So this is the solution region, and we know there is a point here. This point, we just calculate this is the intersection point, right? The 2 and -4, this is called a corner point. Corner point. C-O-R-N-E-R, corner point. Okay, and you see the region you can extend forever, right? So this side has no boundary, right? Has no boundary. Right? Has no boundary. You can go forever. So this is unbounded.